Assalamualaikum warahmatullahi wabarakatuh and greetings from University Technical Malaysia Melaka. I am Masila Kamarudin, the Vice Chancellor of University Technical Malaysia Melaka. Today, I would like to contribute to Icsima 2022 by sharing my thoughts on the theme of the conference by presenting to you a topic that is related to my field of expertise called Requirements Engineering for Quality Instrumentations and Control Systems. The designs of products and services is typically viewed as a process of innovation and development. The objective is to design products and services that customers view as valuable based on their needs, preference and perceptions. Regardless of system, the design of technical products is a process of identifying a market opportunity, defining the problem in that market, developing a proper solution for that problem, and validating the solutions to meet the customer needs, preference and perceptions. As we know, control systems have another important design element that relates to safety. As the risk increases, either in terms of severity or probability of injury, it is critically important that the safety functions of the system does not fail and maintains its system and safety integrity. Now I would like to explain briefly about designing quality systems. In order to design and develop quality technical products, developers have many methodologies at their disposal. The most popular used in software engineering is the waterfall model that has only 6 phases, or currently is the agile methodology. Among these phases, the requirements analysis is claimed to be the most essential phase in the development process since it gives critical impact to the quality of the end product. About 75% to 95% of product launches fail every year. The time and cost to rectify the system deficiencies are more when in fact the requirements engineering phase would have reduced them significantly and also saved the organization the embarrassments of delivering a failed system. How can we design fail-safe system? And how to overcome this? Close attention to detail is essential in the design of all safety-related control systems, whether they are simple hardwired systems or complex systems implemented by software. It is important that safety analysis techniques are used to ensure that the requirements in the specification are met and that a foreseeable failure modes of the control system do not compromise that specifications. Conjunction to this, the Health and Safety Executive (HSE) uses 5 phases to classify incidents, and their analysis showed that the majority of failures were attributed to firstly, inadequacies in the specification of the control system, inadequate safety integrity requirement specification, and inadequate functional requirement specification. Whatever the cause, situations that should have been identified are often missed because of a systematic approach has not been used throughout the life of the system. In terms of good design practice, it is preferable to expend more resources and time to eliminate a potential problem rather than to expend resources later on to deal with its ill effects. Let me describe briefly what is requirements engineering. Ralph Young defines a requirement as a necessary attribute in a system, a statement that identifies a capability characteristics or quality factor of a system in order for it to have value and utility to a customer or user. Generally, there are typically 3 types of requirements level. Firstly is the business level requirements, secondly user level requirements, and thirdly product level requirements. And requirements can be further classified as functional requirements, non-functional requirements, and a quality requirements pertains to a quality concern that is not covered by functional requirements. In requirements engineering, we also have the International Requirements Engineering Board, IREB, which is responsible for the standardization of the method of requirements engineering. IREB is a professional, body comprising of independent and recognized experts from many fields, including economics, engineering, consulting, research and education, who strive to build a professional foundation for requirements engineering. According to IRAP, requirements engineering are based on 4 main core activities. Firstly is elicitation, where the act of drawing out or bringing forth emotions, opinions, facts, needs, and many more. Secondly is the documentation. During documentation, the elicited requirements are described by using natural language or conceptual models. Thirdly is validation and negotiations, where in order to guarantee that the predefined quality criteria are met, documented requirements must be validated and negotiated early on. And finally is the management, where here requirements management comprises any measures that are necessary to structure requirements, to prepare them so that they can be used by different roles, to maintain consistency after changes, and to ensure their implementation. There are also other perspectives on requirements engineering by IIBA and IEEE. How can we deliver quality and safe systems? Many new product designers and developers are eager to start straight away developing the actual product. However, according to many literatures that came from seasoned practitioners, it is important to dwell longer at the requirements engineering stage to ensure that a superior, higher quality and safe product will be successful in the marketplace. Global competition, the reduction of product life cycle, the increase of technological changes, and the level of customer demands have intensified the needs for a more effective new product development process, NPDP. Requirements engineering has been identified to play a vital role within the NPDP life cycle to ensure product performance and its acceptability in the marketplace. Requirements are usually elicited, analyzed, and validated using techniques that are strongly based on the core presence of the person involved. These techniques can quickly become too costly and labor-intensive when used with larger populations. However, with automations, the task of acquiring and interpreting data from very large and heterogeneous group of stakeholders or crowds is now possible. The combined set of techniques for analyzing data from the crowd using text mining and motivational techniques for stimulating further generations of data and crowdsourcing to validate requirements is now called as crowd-based requirements engineering. Another important aspect of requirements engineering that is normally not taken seriously by many designers and developers is requirements reuse. These aspects has been recognized as a capable source of increasing the efficiency and quality of product development process. Since the world has become more agile and more mobile, requirements engineering too has to take advantage of the high availability of smartphones and tablet devices. This movement has given rise to mobile requirements engineering or mobile RE, and many of the requirements engineering processes are expected to be available on mobile apps on a smart device, abreast with the digital lifestyle of the digital economy. The most obviously process to benefit from the mobile requirements is elicitation. Current requirements engineers have to be more versatile and mobile to conduct elicitations. They have to go and meet stakeholders at the time and places where the stakeholders said that are more convenient for them. They elicit requirements by interviewing, brainstorming, and observing stakeholders or focus groups in their surroundings. The collected data can be then transferred up into the cloud, where it will be retrieved later on for the next process of documentation. The usefulness of mobile devices, especially in the 4th Industrial Revolution (IR 4.0) era and the digital economy, is foreseen to increase exponentially over time. With more technological advances to come, it is possible that mobile or digital requirements engineering will be the norm. The importance of requirements engineering has been stressed many times. Regardless of the product design methodology used, requirements analysis has to be conducted to get sufficient and complete requirements to be turned into product specifications. Safety-related systems in a technical product are designed to prevent the EUC from going into a dangerous state by taking appropriate actions on the receipt of commands. As discussed earlier, the main cause of safety-related control system failure is due to inadequate specifications. Although it is not possible to anticipate all causes of control system failure, most can be anticipated if a systematic risk-based approach is employed throughout the life of the system by applying requirements engineering methodology. The process of designing and developing quality technical products will change with the changing times. Not only the quality of the technical product will be improved, but various other aspects, including safety and the product user experience, will also be improved. More importantly, the quality and safe technical product will have a huge success in the marketplace. Thank you. Terima kasih.